minus 4y.
X to the 5th plus 6y minus 4y. So, anybody want to add on to or push back on that?
Yeah. 5 is minus 2y.
5x? So let's just focus here for a second. Why are you saying 5x instead of x to the 5th?
Because 5x, then you add.
Okay, I was going to say, so remember, both of these have 5x's, right?
Yes.
We need to be careful on the difference, though. Why is it this one?
Because you add.
Okay, there's something else I want to say with it. Didn't a lot of y'all go, but Mr. Kenny, it keeps showing this multiplication symbol?
Yeah.
When you typed it in, you got a little frustrated about that? Multiple people did. Taj, why did the calculator keep showing the multiplication? Guys, when we say 5x, what does that mean?
5 times x.
That is 5 times x, but what does 5 times x? It's what?
It ain't repeated multiplication.
It's repeated
Addition.
addition, right? So notice, Vicari, we want to learn from this more. That constant repeated addition is shown through multiplication. That's why for those of y'all who are trying to type in 5x, it said 5 times x, because 5x is 5 times x. It's adding x how many times? 5 times.
So it'd be 5 times x plus 6y.
Well, I mean, it is 6y minus 4y, but remember from there, because I heard minus 2y earlier, let's remember this. What is 6y really?
6 times y.
But what is that really? So it could be 6 plus 6 plus 6, y number of times. We don't know how many that is. But I could write this as y plus y plus y plus y plus y plus y. 3, 6, bet. All right, what's happening to those 6 y's?
Subtracting it.
I'm subtracting it by
4y.
4 y's. Not by 4, but by 4 y's, right? Okay? So J Mike, tell me this. What's y minus y?
0.
0. What's y minus y?
0. 0.
What am I left with?
2y.
Now, are those positive or negative?
Those positive.
What am I doing with those y's? I am adding them, so they are positive. So remember, J Mike, you said minus 2y?
Yeah.
Let's see how I have 2, whoops, not x to the 5th. 5x plus 2y. Please do not forget, at its core, multiplication is repeated what? Addition. And I don't necessarily want you to write it out this way every time, but if you can see this as adding y 6 times, and then taking away y 4 times, that explains why it's 2y. I had 6 of them, and I took 4 of them away. So keep that in mind. It's going to help when you understand or look at linear functions. Okay? Next one. Now this was to expand our understanding a little bit, but this is going to be important in a second. So x times x times x times x times x times 5 to the 6 divided by 5 to the 4th. Now I'm building on something that you hopefully talked about in Algebra 1, but if I'm putting it as a bell ringer, I need to pay attention to it because it's going to impact our ability to be successful in a minute. Alright? You with me, Makaria? Okay? So, most of us, ooh, we're all over the board on this one.
Oh, wow.
Yeah, that's what 5 to the 6th is 15,625.
Yep.
Yep. But I feel like I could have made that easier.
No.
Hey guys, think about this. We talked about it over here. Repeated addition is shown as what?
Multiplication.
Multiplication. So Alexis, what's repeated multiplication? So be careful about when we have repeated addition that's simple or singular multiplication, right? But I have repeated multiplication here. So remember, if we have a constant multiplicative rate of change, what type of function is that? Exponential, right? What's repeatedly happening here? I'm repeatedly multiplying, so it's going to have an
Exponent.
right? Like when we say exponent, what you want to think about, at least with a whole exponent like that, is repeated multiplication. We go with that?
Yeah.
And that's why, I'll leave it like that for now. Okay, now, so 5 to the 6th is 15,625. 5 to the 4th is 625, but there's a way easier way to write this. Does anyone know what I could have done here?
Multiply. You subtract.
Divide.
You would have added them to the exponents together when.
So
Subtract.
one, I'm gonna start building on some of these ideas. What's quite literally happening with that fraction bar?
Divide it by.
We are dividing, right? But how am I gonna divide it? Now, J. Mike, you said I'm gonna add those exponents together? Yeah?
Yeah.
Okay?
I just kept it exponential, calculate like 5, 6,
But, well, I'm gonna even put this into the calculator. I want you to think about this. What does 5 to the 6 really mean?
5
5 times, 5 times, 5 times.
5 times 5. How many times am I doing
6
this?
times, 6 times.
Divided by
4, 4 times.
5 to the 4. 5 times, 5 times, 5 times, 5 times.
Okay. Hey, quick question. Come on, what's 5 divided by 5? 1, right? Okay. Chelsea, what's 5 divided by 5? Huh.
Oh, we.
Bakari, what's 5 divided by 5?
1.
Bakari, what's 5 divided by 5? So what am I left with?
Oh, 2 5.
I'm left with how many 5s?
1 5.
2 of them. So how am I going to write this?
5 to the 6.
5 to the 6.
5 to the second 5. Remember, I have 2 5s, so 5 to the second.
I said.
So, J. Mike, should I have added those exponents?
No.
What could I have done?
I said it's a trap.
I know, I heard you. Okay.
Dude.
So I want y'all to see this. This is known as a power ruler, an exponent property. Notice it's the same as over here, right? I was repeatedly adding, right? And then I was repeatedly taking away.
Yeah.
Here, I'm repeatedly, what's happening?
Taken away.
No. Repeatedly multiplying. And because, what does this fraction bar mean?
Divided by.
So I am repeatedly multiplying, then repeatedly dividing. I subtract the exponents because what did I do? I divided.
Divided.
And the inverse of multiplication is
Division.
division.
But if you get a negative, like if you get a negative exponent, you gonna this one you gonna add.
Not quite. Good question. I wasn't planning on talking about this right now, but I will. So 5 to the 4th divided by 5 to the 6th. So what I would point out about this is if I subtract the exponents, 4 minus 6 is negative 2, right?
Yeah.
Okay. But couldn't I have also just written it this way?
Yeah.
And so those cancel. And so what am I left with? 2 5s in the
Denominator.
denominator. All a negative exponent means is to divide.
Alright.
Literally anytime you see a negative exponent, it just means divide. A positive exponent, or positive integer exponent, means to repeatedly multiply. A negative exponent just means to divide. It's that simple. Does that make sense?
Yeah.
A little bit? Okay.
So
So
like that-
here's what I just want us to understand these ideas of exponents a little bit better because it's going to help us when we start trying to write these exponential equations again. The thing I'll point out is this. We know that this can be 5 to what power?
4.
The 4th, right? But what if it keeps going and I don't know how many times it keeps going?
5 to
What else
the
you
X.
get to?
5 to the X.
Notice if I don't know, 5 to the x power is an unknown number of times, a variable number of times. So when we talk about those exponentials, right, we have a variable exponent. Why is it a variable exponent? Because I've repeatedly multiplied, but it can change, right? Don't know how many times I've multiplied.
Yeah.
Okay, so that's going to explain these here. Y equals 7 to the 5x. 7 times 5 to the x. Almost everyone said what type of function here? Exponential. Why do we know that's exponential?
Exponent.
Those got to be.
I mean, and all the formula. A times B to the X.
There is something about that. So I will point this out. What about this? Would this be exponential?
Yeah.
Why do you think that?
There's an exponent over.
It does have an exponent, doesn't it?
Yeah.
Do you agree, Dewan, that this is going to be exponential here?
Yeah. Wait. Yeah. Something like that. I don't know.
Okay.
Quadrilateral. Oh.
So remember how we did this is literally from the data with Dr. Johnson last week. You remember how we looked at position and time, and we had the x squared, and it created this parabola?
Yeah.
Oh,
If it's x squared, is it exponential?
Oh no, it's quadratic.
It's quadratic. Look at these two again. Are these the same?
No,
No.
Which one's exponential?
the two. I meant the
$1.5
X. The exponent. 5.
1.5.
5 to the,
X.
we need to notice, remember I just talked about it, if I'm repeatedly multiplying by 5 and I don't know how many times, it's 5 to the x.
Yeah.
That's exponential. If it's x squared, what's that going to be?
That quadratic.
If it's x squared, it's going to be
Quadratic.
quadratic, guys. So we want to hold on to that, note that,
Anything
right?
squared is gonna be quadratic.
That is at least the pattern we've noticed so far, yep. Remember, do I still have the data in here? There we go. So, remember how we did the dice on Friday as well? And when we did the dice, and it was repeatedly multipliable with 1.4, and it's raised to the x? Right, Jay Mike? So when we're repeatedly multiplying, it's raised to the x, that's that exponential idea?
Yeah.
Okay, if it's x squared, it's been quadratic. And we want to be careful about those details. Alright. I'm just going to check this. There, perfect. Alright. So, I just want to point out that we have now at least, if we're looking at these proficiency scales, I'm going to move through this quickly because I want us to get some practice in before lunch. Looking at these proficiency scales, we have looked at determining if a relation is a function, type of mathematical representations, and so all those terms under identifying functions. The only thing we have not really done a whole lot is quadratics. But that's where we're going to start at the end of today.
Yeah.
Alright, so we're going to have a demonstrated understanding to start tomorrow on linear versus exponential functions and equations. But I would plan to do a demonstrated understanding on identifying types of functions probably on Thursday. I know that sounds really quick, but I waited on the linear and exponential. Say again?
That's a little too close.
They're not. I need to check on your understanding. We got to know those three. All we're doing is adding in the quadratics. And so it depends on how far we get today, but that's what I'm planning for right now. And then we got to be able to determine if two relations are equivalent and explain why they're equivalent. That is something we are going to do on that same demonstrated understanding. So that'll either be Thursday or at the absolute latest Friday. And there's our types of functions. So what we're doing today, though, is we're focusing on functions with constant rates of change. This is the on that yellow proficiency scale. Preston, when I say functions with constant rates of change, what do I mean by that? Mm-hmm. No clue. Oh no.
What did you just say?
I said when we talk about functions with constant rates of change, what am I referring to? Cameron, you know which functions I'm talking about when I say constant rates of change? Not sure, Caden? Functions with constant rates of change? No idea? Mel?
Is it exponential?
Exponential and linear. Bakari, what type of rate of change does a linear function have?
Rate of change, then add and subtract.
Okay, so I need some more details with that.
Like
DJ?
That's the additive.
Constant additive rate of change. So is that a constant rate of change?
Yes.
Yes? Okay, Chris, do you remember what type of rate of change an exponential has? Is it just multiplicative?
and
There's another word with that multiplicative. Constant multiplicative. Remember, like when I say constant rates of change, guys, I'm talking about the constant additive rate of change for a line. By the way, Jamie, what's the constant additive rate of change called? It is a linear function, but what's the name of that constant additive rate of change? Don't remember?
I don't know why you asking me. I don't know.
Tyler?
You said slow.
Say again? Slow! Guys,
That's it.
when we talk about a line,
That's it.
what's the rate of change of a line called?
Slow.
Slow. So when we say constant additive rate of change, what's that also called, Addison? Slow. Jamie, constant additive rate of change is called? What'd you say? No, what you gonna say?
What Kofalat just said.
What is it? No, thank you. Okay. But then constant multiplicative rate of change is for what type of function?
Exponential.
Exponential, okay. Does anyone remember what the name of that constant multiplicative rate of change is?
Constant, hold on, wait.
Constant factor.
Hey guys, don't forget,
I'll finish
this
it.
is why we also have our proficiency
I
scale.
saw I'll finish it. That's multiplicative.
Is it not on the backside?
You gonna say the name, I said multiplicative.
Y'all should have two. If you don't, or if it's not on the backside, let me know.
I don't have none.
We got one.
I know, that's why when you pull this up, I be looking real long.
Okay.
That shit already done.
I need another one. Then.
I think Mr. Harvey got some.
Oh, the numbers of the printer did not, the copier did not work out.
I think Mr. Harvey
Well,
got
do
some.
that.
It's working. Oh, these are on the backside. Oh, they're sitting on the backside.
Here's one with constant rate of change.
Mr. King.
Here, that's what he said.
That's correct. Yeah, just hand that way. Okay, we got one coming out then. I thought you all had it. Go for it. Yes.
I just take it out and.
Okay. Alright, so, Mr. Hawkins, you're gonna give it to everybody, and if they don't need it, then they
These
can
don't have
scratch
the
it.
back.
Huh?
I think they're missing the one. These don't have the back.
No, they don't, y'all don't have the constant rates of change one.
Yeah.
They have the identifying functions, they don't have, some of them have it.
I have no. Yeah,
Yeah, that's what I'm saying, just give everyone the constant rates of change. So, just trash that one. Later, alright. So, constant rates of change, we need to know those details, sorry, I thought y'all already had that proficiency scale. But, yeah, that's it. Not because we didn't pay attention and take the notes of Mr. Kenny has to take. Study them. What? Nothing. Alright, so, listen. We need to be able to determine the rates of change, we need to be able to identify the types of functions. Because here's the thing, I'm asking you to write these equations. You've got to be able to identify the type of function. So, we're about to work on that practice sheet, but I need y'all to remember this. First things first, if you want to write an equation, what's the first thing you need to do?
Look at it.
Look at the form.
Oh, you gotta find the which color.
Let's find what kind of, if it's a linear or exponential.
Alright, so to write an equation,
Good job,
First.
little man.
what's the type of function?
One is.
Well, I'm just saying that you need to answer that question, right?
Yup.
2, what do you need to identify based on that type of function?
The form.
The way it's performing. It's like
Right.
It's division or multiplication.
Well,
Or if it's adding or subtraction, right?
there's a formula or an equation for each type of function,
Right.
right? If I have a linear, what's my equation?
Y equal mx plus b.
Okay? And once you do that, hopefully that triggers something that helps you remember, hey, I know what M is, I know what B is, or I know how to find them at least. And if it's exponential, what's the equation?
A times b to the x.
It's not equal.
Okay. So, and then remember what those things mean. Now, I will remind you, my linear function has what type of rate of change? Constant additive, right? Chelsea, how do we show repeated addition? Multiplying. Is that what you said?
Multiplication.
Right? Multiplying. M times. That's my constant additive rate of change. Jaquel, how do I show repeated multiplication?
Exponent. 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 Exponent.
What is it? An exponent, right? So when I look at this exponential equation, you see right here where there's an exponent? That means this is my constant factor, right? So remember guys, the equations tell you a lot about the natures of the function and what to find and how to find it, okay? So you all should have a practice for linear versus exponential and writing equations. So remember it started out with these directions at the top.
These right here.
Hey, big bro, I don't know what that is.
Yeah. We started it last Thursday.
Oh,
We worked on it for 40 minutes in class after lunch on Thursday.
I don't think that was Thursday.
It was Thursday.
I think that was Friday.
Dog, Dr. Johnson was here Friday.
Oh, he was. Oh, that Wednesday? What?
Dr. Johnson was here on Friday.
Oh, yeah.
Oh,
Yeah,
yeah!
that scooter dude.
Yeah. Alright, so what I need us to do is start working on this. Yeah. So I need you to get up to your vertical surfaces. We should have already finished through number 6. So what I want you to do is, Yes. All right. Hey, pause for 1 second, really quickly. Hey, eyes and ears right here. Start on number 7 and continue working from there. All right.
We ain't got to do
What if I
one.
don't know number 7?
Huh?
Then you say we ain't have to do 1 and 2.
We're skipping 1 through 3. We're gonna come back to those at the end. I want you to work on number 7 right now.
What, can I skip number 7 if I don't know it?
Huh?
If I don't know it?
No, do number 7.
Ah.
Anybody else need a copy of this?
Oh, shit, I need one big one.
How can you check? So like, so. I'm gonna make a table. I can clearly see some just 2. Output of 0, output of 30, output of 6, and the input of 2. So that's for that graph. And I can give you you said this equation. How could you use that graph with this table to check? How could you use this equation?
Plus 5.
Number 7. You could keep it going, but you're gonna find out. What is this in? So does it matter which representation you have?
Bro, I cannot. No, it's so oh God,
Remember over here, we were talking about y intercept.
That's 2 times 3 is 30.
How our axis is right, that big line, that's our y-axis.
30 was 3 squared.
The value in which we intercept.
I say 3 times 3 is 9. 2 times 5.
Now,
Tell me.
you know something about the x values on the y-axis.
That is, right? Each input is mapped to the same output. Now, make sure you're not Come on, what you doing? I don't see anything written on these boards, guys.
But I'm focused on this line, this giant line, whatever. That's my y.
You got 2 minutes. Wait till we go to the
Yes,
Yes, you can. Yes, you can.
So what is the x value?
What is
It's kind of what is that?
I want y'all to look at it.
I ain't even.
What does that look like? Does it look like a line? Y'all making that way too fast. Second, let me point this out. Did I ever say you have to keep it as a graph?
These are y. Doesn't matter what direction.
You got it, which side, right on my board?
Do you have to just look at that graph to figure out what type of function it is? Can you make a table of this one for me real quick?
What is my x value?
By the way, ignore the -1 point. Look at the other 3. Hey guys, we have nothing on our boards yet.
Brother, I can't get to my board.
Alright, get to your, Maya, get to y'all's groups. We need to get going.
Okay.
No, y'all to the left. Y'all prevent this group to get going. Which number are y'all on?
I'm gonna say my son about some questions.
So,
If I can get your eyes and ears over here, Taj.
Yeah, so
I just
students
want to set this up
can
really well. So I want to point this out. First things first. As soon
Yeah,
as you look
great.
at number 7, what did y'all notice?
It was exponential.
How did you know?
Exponential curve.
Now be careful, and I want to point this out. Can I just say, hey, the graph is a curve, so it's exponential?
No, I can say it's exponential curve.
Okay, listen, right here. I need you all to pay attention to this. If you were to see this graph, would that be an exponential function?
No, that'd be a parabola and a quadratic function.
Right? So please hear me clearly.
trying to find a good angle.
When I ask you for evidence about what type of function it is, you cannot
Appreciate
just say, hey, the graph is a function. Also, don't use the word it. Be clear with your language, right? So the graph, right? What's the name of this type of curve? Exponential curve, right? So we know it's a graphical representation. The function is an exponential because we have an exponential curve. Now, Chris, what was the problem you ran into, though, when you were trying to write this equation? Ooh, sorry, I forgot something. Hold on to that, really quickly, okay? You're hot, I mean, I'll gladly turn it down.
How far you gonna cut down, big bro?
I got it down to 68. Alright,
Wait,
eyes and ears. Hey, listen. As soon as we say, hey, that's an exponential function, what's the next thing I need to do?
Say, oh, here's on the exponential formula.
Right, guys, hear me clearly on this. If you take the time to write the equation out after identifying the type of function, it makes your life way easier. I'm not just saying write out the problem. I'm saying, hey, this is an exponential function, so here is my equation that I'm going to work with. Right?
Yeah.
Addison, do you know what this A is then?
Is the,
Come on, you
is
got
it the
this.
slope?
It's the what?
The
The y-intercept. Now, I want to pause, I want to point this out, and we don't need to note this. Could it be slope?
Something like that. Oh, no.
No.
That's for linear.
Say it again, Dewan.
That's for linear.
Hey guys, please be careful and remember, students try to do slope all the time with an exponential function, but a slope is what?
Linear.
Yes, it goes with the linear, but what is slope?
Slope is rise over run.
Constant, additive, rate of change, right? When I say slope, what I mean is a constant additive rate of change for a linear function. And so, yeah, not slope, but what is it, Addison, right here?
The y-intercept.
The y-intercept, right? Chris, what was that y-intercept? You found it in your equation. It was 2, right? So boom, y-intercept 2 times. Now, if that's the y-intercept, what do I still need?
You still need x in. I mean, you still need the.
Remember, slope is only for a linear function,
Yeah,
right?
you're right, my fault.
Now, slope is a rate of change. Do I still need a rate of change?
Yes.
Yes. Okay. Hear me clearly on this, guys. A line is really easy to see the rate of change on the graph.
Yeah.
But it's not as easy to see it with an exponential. Most of the time I see students try to do this. And they'll say, +4, +1, and so that is a 4. But what is this going up and to the right? That's literally what? It is a rate of change, but which type of rate of change? Which is slope, which is, what's this plus mean?
Additive.
Additive, right? We don't have an additive rate of change. We got a multiplicative. So what did I have Chris create over there to help see that rate of change really quickly?
Oh, a table.
Guys, rates of change are really easy to see in tables. As soon as you look at this, what's happening to go from 2 to 6 and then 6 to 18?
Addition.
Is it?
Oh, multiplication.
Multiplying by what?
3.
Good job, Carl.
There's my equation. So, once you identify the type of function, right, create or write out the formula and then fill in the pieces. You gotta know what the A and the B mean though. It's not just magically coming up with a value. If you understand that A is y-intercept, it's really easy to find. If you understand that B is my constant factor, you can find the constant factor in various ways. So take advantage of that. One thing I will remind you, because sometimes it gets more difficult, it's also possible to say, hey, 2 times f is equal to 6.
Yep.
Right? And find your value for f. So keep that in mind as you move through this.
That's
Boom, boom.
Well, f is equal to 3, and that's my b value right here, so this is my equation. Notice how I have evidence for it. If you want to take a second to write down some notes for number 7, do that, and then let's continue on with 8 through whatever we can get to. I'm going to move us to a different thing in a second.
May I take time to come in?
You know the rest of it now.
Thank you.
We haven't done any of the graphing yet from an equation, so I'm probably convert it to a table. First off, be careful and make sure you only have points that you can clearly identify. The only 2 points you can clearly identify on this graph are -1, 100, and 0, 80. Any other points are going to mess you up. So look at that graph again. Okay? But, hey, I know you're probably like, Mr. Kenny, I need more than 2 points. But do you? What type of function is this? Exponential, right? Most of us are identifying that 80 for the y-intercept. But what is going to happen every time for 80 for an exponential function? It's going to repeatedly what?
Multiple.
Say again? Multiply, right?
Yes, sir.
All right. Right away, do we know what we're multiplying by?
No.
No. So what can I use to represent something I don't
F.
know?
Factor.
So a variable, and I would use f for factor. So 100 times whatever my factor is equals what?
80.
Hey guys, do y'all know how to solve an equation to find out what f is? If you don't, then you need to work with your group and I'll come by and check on y'all. But guys, I need y'all to remember, use efficient strategies. If you know, hey, I'm multiplying by something, but you don't know what it is, what can you use? A variable. And the whole thing I'm trying to emphasize and point out is you need to know that I need a constant factor. So multiply by f, even if you don't know what it is, use a variable in that case, set up your equation, and find out what f is. Because you're almost there already. Let's get to it. Keep it going. Mr. Hobby, while I'm talking about this with them, can you pass? Y'all have not gotten this sheet yet, have you?
Of course not. No, pretty sure not.
Okay. All right. Really quickly, I just want to point this out and I want to address this. So, first off, I want to remind you, right? Keeping our hands to ourselves. Okay. 2, and actually what I really wanted to say is this. Remember, what is the very first thing you need to do?
Determine the
Type of function, right? A lot of us are getting pretty good at that. But what should you do immediately after identifying the type of function?
The formula of the equation.
Right, guys, here's the thing. You don't have to. You can get the right answer without doing it. But every time, the students who do this thing that I'm asking you to do right here end up being significantly more successful because they're used to following a set of steps, a set of logic, really. Write out the formula, plus the formula is going to help you understand what to do. Write out your formula based on whatever type of function you're dealing with. And so once we realize, can you open the door please? Once you realize that, you have your y-intercept, you need to find your constant factor, and you can move forward. So hopefully we all got our equation, right? 80 times 4/5 to the x. There's some good work here, so I'm going to leave this here.
Yo.
Okay?
Good work.
Other places have it as well. But what I want to look at quickly, because we got to move to a different set, is this, really quickly, right here. Let's talk about number 9 a little bit. Just glancing at number 9, anybody have an idea what type of function we might be dealing with?
We might be dealing with the exponential
What number you said?
What would give us a hint with number 9 that it's exponential?
because the division signs.
Yeah, guys, you see how there's a fraction bar right here?
Yeah, fraction.
And there's not one here?
Yeah.
Yeah.
So that's probably something to do with multiplying, right?
Most definitely.
More than likely something with exponential. Okay, so those are things that we want to notice, right? So we need to identify the type of function. Notice how my first inclination then is to say, hey, I'm multiplying by a factor. I may not know what that factor is, but let's look at it this way. What does 20 times f have to equal?
15.
15.
Let's go.
I thought it had to be.
So now I have 1f is equal to 3/4.
Yes.
Okay, so let's check this. Watch what happens here. This is why I like fractions. What's 3 divided by 3?
What?
Understanding that fraction bar is division instead of just saying over
Yes.
makes this math make more sense. What's 80 divided by 4?
20.
Boom.
Oh my God.
And if I take 20 and I multiply it by 3/4, what's 20 divided by 4? What's 5 times 3?
15.
Okay.
No, that's crazy.
What's 15 times 3?
45.
Divided by 4. That's all it is.
No, that's tough.
That's it. Right, Preston? Jamie? Look, so here's the thing. Now that I know I have a constant factor, I know it's exponential, right? I've identified the constant factor, I've identified exponential, so what's the very next thing I need to do?
Write down your
Write
formula.
down the equation.
Yeah, your equation. Formula.
And the beautiful part about this one is, I already know what B is.
Yes.
What is it?
Oh, B. Yeah, 3 or 4.
3/4. 3 divided by 4.
Yeah, 3 divided by 4, sorry.
Now, I will point out, do you know what your y-intercept is?
No, you gotta keep going.
You gotta keep it going, I gotta go up, right?
Yeah.
So, if I'm multiplying by 3/4 this way, I'm gonna divide by 3/4 or
That
multiply by
way.
4/3, go back up.
Yep.
But, there's that. Next. So I'm gonna leave that there if you wanna get some information later, but number 10. What should immediately jump to our brains about number 10?
Linear.
We all go with linear, right?
Line.
Okay,
Yes.
as soon as you see linear and just say the graph is a line, bet, cool. As soon as you say it's linear, what's the next thing you should write down?
The formula.
Yeah, what's that formula?
Y equal MX plus B.
Hey guys, hear me clearly, B, mx plus b. I need to say this clearly. Every time you write down that formula, you know what's going to happen?
I'll be like, dang.
It's going to make it easier to
Sink in.
Learn.
sink in and remember.
Learn.
Learn it. Guys, write it down every time. It's not a mystery. The more times you take repetitions, the easier it is to remember something. Right?
Yeah.
J. Mike, in football, you ought to take a lot of snaps, right? Make sure that you know exactly
I'm
how
on
to do.
defense.
Huh?
I'm on defense.
Well, you just kidding.
Reps.
I knew that. You gotta get a lot of reps in, right?
Yes.
There we go. But you gotta practice it over and over and over again to make sure you get it down, right? That's how it is for all sports. That's how it is for academics as well. Practice, practice, practice. Okay. But write it down, fill in your information. Now, the reason why I wanted to talk quickly before we move to the next piece is this one, number 11. Is it a function, first off?
Yo. Hold on. No. They got 2 zeros. 3. Actually, but
But look again. Tosh, what does -4 map to? Does it map to anything else?
no.
What does -3 map to?
Q.
What does -2 map to?
0.
What does -1 map to?
0.
What does 0 map to?
Q.
So each input maps to
One output.
one and only
Only one
one
output.
output. Guys, your outputs can repeat.
Yes.
Your inputs cannot.
Cannot.
Oh.
Okay? So is this a function?
Yeah.
Yes.
What's that?
Maybe linear. Let's find out. -4, -2, +0, +2. Well, that's definitely not constant additive, is it?
No, not at all.
Not at all. But what happens to go from -4 to -2? Add 2. -2 to 0?
And 2.
0 to 2?
And 2.
So that's constant additive, isn't it?
Yo.
And so this would have to be, what's always constant additive?
Linear.
Linear, so this would be a linear
Additive.
additive.
Rate of change.
And so, hold on, Jamie, I'm glad you said that. Notice, this is not my function, is it?
Bro.
This is my function. This linear is a rate of change. And someone said, Taj, you said it's what type of function?
I said quadratic.
Yes,
It is
sir.
quadratic. A quadratic function had that linear additive rate of change. Remember, we looked at that at the end of Dr. Johnson's thing. Yeah, and so if I graph this also, -4, like 6 would be here, -3, 2 would be here, -1, 0, 0, 0, no, -1, 0, and then 0, 2, which that's way off. It's just a quick sketch, but it would look something like this. Notice, isn't that easier to tell it's quadratic from the graph?
Most def.
So can you make a graph to make sense out of it?
Yo.
Most def.
100%.
I got a basketball in here though.
Okay. That was, oh, we didn't end up using that, did we?
No.
That for yesterday.
We didn't get a chance to do it on Friday. All right,
Kobe.
so really quickly, I want us to look at that sheet that Mr. Hobby just passed out that has 6 equations and coordinate grids.
Mr. Harvey passed out the sheet.
Should be on your
Can
table.
we do one together?
Should be on your table.
No.
It's on your table, guys.
Look.
So,
Should be.
number 1 on here. First off, what am I asking you to do in each of these cases?
Oh, yeah.
I want you to what? Identify the
Type of fraction.
type of function and create a table and a...
Graph.
Okay,
Thank you.
so first things first.
Bad, Karen. You a dog.
If you write the equations on the sheet,
Cam is right here.
what type of function we dealing with?
Oh my, you said what?
Number 1, what are we dealing with?
I meant linear. Linear.
Linear?
Yeah.
We'll go to linear?
Yeah.
That's my fault. I can see.
Y equals mx plus b?
Yeah.
Okay, so I want you to create a table and I want you to create a graph. Anybody know any key points to start with?
0. Wait, 3.
Well,
Wait,
no,
negative 7.
Go up 3 times, then we cross over to 2, possibly?
What is he referring to? Go up 3. So that's my slope, right? But that's not a point.
But then you asked.
That's how I change.
You asked about the table, right?
When I say start at -7, what do you mean by that?
Like, that's what the first point is.
Negative 7 is not a point.
That's how it
That's
would.
not y.
I mean, oh, why?
Y-intercept. Remember, y equals mx plus b. So, you said start with the table, right?
Yeah.
Could I start with the table?
Yes, you got your point.
Okay, so 1, 2, 3, 4, 5, 6, 7 be here. Or 0, negative 7 here.
That's what I was saying.
Notice I can start with table or graph based off of the y-intercept,
But that,
right? From there, what can I do?
Pretty much a whole bunch on the wrong side.
Hey guys, what can I do from there?
factor.
You put the 2 on the X and the 3 on the y.
Well, you said it earlier, Bakari.
Oh wait,
It's the slope, right? So I'm gonna go up how far?
3 times.
Up 1, 2, 3.
Yes.
To the right, 2. Up 1, 2, 3. To the right, 2. Up 1, 2, 3. To the right, 2.
The way started.
Okay? So, there is my linear function. Okay? Notice from here, can I take these points and put them into a table? Yeah? Notice this would be 2, negative 4. And 4, negative 1. And 5, 2. And I want you to notice that this should make sense because what's happening to my y values? I'm adding 3. What's happening to my x?
2.
Oh my goodness, it's just like the slope. Holy cow.
It's crazy.
Right? That also allows me to go backwards to negative 2 and negative 10. So, I want you to create a graph and I want you to create a table for every single one of these. Use what type of function it is, use the points and the rates of change that you know. I want you working with each other for the next 4 or 5 minutes to get started on this. Huh?